we are going to learn about relays. So what is a relay? What are relays? Relays are electrically actuated switches. The three basic kinds of relays include mechanical relays, reed relays, and solid state relays. But in this tutorial we're gonna just go through the mechanical relays. Solid state relays, we're gonna do it when we are gonna learn about thyristors. So now we're just gonna learn about relays. So go here into your library and you can go here to the category and click on switches and relays. So I learned you about switches. I talked about switches in my previous videos, and I show you a button and I show you a mechanical switch just here. But those are switches that act when there is a mechanical force, not an electrical force. But in a relay acts when there is electrical, there's some electricity, and then that electricity will act as a switch. So there are a lot of kind of relays, as you can see, but we are gonna just do some DC relay, and you'll go here and take this animated relay model. So double click on that. These all relays are called. Here you can see the schematic model, and here you have the PCB model. This relay here is gonna show you just on the schematic when I simulate the program what is going on. So we have this kind of relays we have with 2 poles, but for now I'm gonna just take this one. It's okay for me. So here are a lot of kinds of relays models, a lot of company with other coils, and so on and so on. So now I'm just gonna take a relay. Now when you want a DC relay, always you have to connect a diode in parallel with the relay, because it's kind of hard to explain it with words, but just trust me, you always need a diode in parallel with the relay to prevent the inductive spikes of the relay or of the coil. So I'm gonna take this one diode, sorry, that is called 1848004 diode. Okay, now I'm gonna take a lamp here, and now I'm gonna take one switch or a button. I'll take a button, and I need a battery. So I'm gonna explain the working of a relay with an example. So now this is all I need. Now here, when I put a relay on the schematic here, now here we have a coil, we have some magnetic material here, and when the current passes through this inductor, it produces a magnetic field that attracts this metal rod to the other pole here, and every other relays have voltage. So if you now this is a relay with 12 voltage, 12 volts. So if a 12 volt is passing through, or if this inductor is on 12 volts, it's gonna attract the metal node. So there are a lot of types of relays. So if I go to edit properties, now you can see the coil resistance. It has a resistance, every has one, and now I'm gonna put 6 volts here. So when I apply a 6 voltage when I apply 6 volts on this coil, this is gonna uh, pull this metal into the other pole. So I'm just gonna make an example. Here we are gonna make a simple DC activated switch. Okay, so another thing is we didn't learn about diodes, but it's always good to put up diode. If you have a DC current, you have to put a diode in parallel with the coil. That prevents the inductive spikes. So basically, this produces a magnetic field, and when you turn off the voltage, the change of the magnetic field is gonna induce a current that will go in the opposite direction, but this diode will prevent that. It won't. It's not gonna break itself. So it's really a good thing to always put a diode parallel with the coil. But it's kind of hard to explain it because you need, I need diagrams, graphics, and all that. But I don't want that much education in this tutorial. So now here I'm gonna put a button or just like here, and I'm gonna put a battery here, and I will change the voltage of this battery to 6 volts. That is enough to magnetize this coil and activate the relay. So now here when I just connect like this, I'm just first gonna show you, and I'm just gonna animate this program to you. Now when I simulate the program, it will take a second. Nothing is going on. Nothing is going on. See, here is the metal. Now I turn blue. There is no current or a voltage going through this coil because the switch is opened. So if I close the button, as you can see, there is an applied voltage, approximately 6 volts, that acts on this inductive coil. It attracts. There is a magnetic field produced here, and that magnetic field will attract this metal. So now you have here the contact, and it also depends what is going on in this secondary circuit that I'm now going to make. So if I open the switch, there is no current, and metal goes back to the first node. And now I'm gonna stop the simulation. Now I'm gonna make a secondary circuit. Now put a battery here. You can leave it at 12 volts. Now just a second. Okay, so and here put two lamps in like this, and connect this one here. Okay, just do what I'm doing if you are on Proteus or just watching just a minute. Now, when the metal node is here, then the current will go from plus to the minus and go here. It won't go in this way because here you have an open circuit, and this lamp is connected here where is an open circuit. But if there is no applied voltage here on the coil, then this lamp will work. If you apply a voltage on this coil, it attracts this metal node on this pole, and you will see that current will go to the second lamp. So when I simulate the program, as you can see, there is an open circuit here. The coil isn't energized, and you can see that this first lamp L1 is gonna glow. The current goes here. the current won't go here in this direction because here you have an open circuit. Now, if I close the switch, I energize the coil here. That attracted the metal node on this side, and as you can see, the current from this battery is going here, 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 and here, and it goes through this lamp too, and it's energized, and so it goes. The current will not go in this direction in the first lamp because here we have an open circuit. So this is a basically DC actuated switch. I just showed you how a relay works. Uh, I told you that you have to put if you have a DC coil, DC, if you have a DC relay, and those relays are, most interesting for us electronics engineer. You always have to put a diode in parallel, of course, and this is kind of practically it. So there are a lot of types of relays. We're gonna do a lot of examples in the next in the videos in the future. So thanks for watching, and that's it for now. See you in my next lecture. Bye.